Hello, I'm Alan Fulton, Irrigation and Water Resources Advisor for the University of California Cooperative Extension, working in the northern Sacramento Valley. Welcome to this tutorial on using our crop ET reports to make basic irrigation runtime calculations and other simple conversions. This is a place where this information starts to become more applicable in making on-farm water management decisions. In order to use our weekly crop ET information, you need to have irrigation system information as well. Our goal is to be able to estimate maximum weekly irrigation run times based upon each weekly crop ET report. You must have a reliable estimate of your water application rate for the irrigation system. And we'd prefer that it be in inches per hour, but we can work with it if you know it in terms of gallons per tree or vine per hour. I'll put out the reminder that the higher your irrigation distribution uniformity, or the better your system is maintained and operating, the more efficient and effective you can be with your efforts to use this information and schedule when and how much water you apply. So for this tutorial, we're going to work through a couple of examples using the weekly crop ET reports and information about specific irrigation systems. We're going to start with a walnut example, and we're going to use the ET reports, the information as reported in inches per week. In this example, we're going to be working with real data that is from a walnut orchard that uses a solid set sprinkler irrigation system. In this case, this solid set sprinkler irrigation flow is high enough that the nozzles are rated in a gallons per minute flow rate. So we're going to work through this by hand, how you would do it yourself to calculate the hourly water application rate in inch per hour. So the basic information starts with there are 90 trees per acre. It's a solid set mini sprinkler system, one sprinkler every other tree, offset every other row. This is a very common design. So that would make for 45 sprinklers per acre. The nozzle flow rate is 1.2 gallon per minute, and I'll emphasize gallon per minute, an operating pressure of 35 pounds per square inch. So to calculate by hand the water application rate, the math looks like this. You have 90 trees, you divide it by 2 because there's one sprinkler for every other tree. You then multiply by 1.2 gallons per tree because that's the flow rate rated for the nozzles at that operating pressure. And then you multiply by 60 minutes per hour to get to the gallons of water applied per hour on a per acre basis. So you crunch the numbers with a hand calculator or calculator on your computer. You should come up with a number of 3,240 gallons of water applied per acre per hour with this system. Now, a very important conversion factor that I challenge you to commit to memory is there are 27,154 gallons of water in an acre inch of water. That is 1 acre of land covered 1 inch deep with water. 27,154 gallons of water in an acre inch. So if we know that in 1 hour with this solid set sprinkler system, we are applying 3,240 gallons of water across 1 acre, if we divide it by 27,154, it gives us a calculated applied water rate of 0.12 inches per hour. 0.12 inches per hour. And you can think of this as a precipitation rate, much like we hear the weatherman report our rainfall intensities when storms come through. And I'll just reemphasize one more time, this conversion factor, 27,154 gallons of water in 1 acre-inch of water. So I walked you through the hand calculation because I think it's good that we all understand the process and have some practice with it. To simplify, we have offered on our Orchard Source website, Sac Valley Orchard Source, we have offered some calculators, created them. And here is an example of a live link to a calculator that will help you calculate the hourly water application rate for mini sprinklers or solid set sprinklers that have nozzles that are rated in gallons per minute. This is a screenshot of the calculator. It's fairly simple. It asks for specific information, the flow rate of the sprinkler or solid set sprinkler that you are using in gallon per minute. So in this case, it's 1.2 gallon per minute for each individual sprinkler. The number of sprinklers per acre, 45, and then it does the math for you, the 3240 gallon per acre per hour, and the conversion to inch per hour, acre-inch per hour of 0.12 inches per acre. Or we just say 0.12 inches. So now we have our hourly water application rate. Let's work through an example of using our weekly ET report to arrive at a maximum weekly irrigation runtime. So this report is from actually today of this recording for June 5th through June 11th of 2020, actually through yesterday. Going to use data from the Durham area in Butte County. As I said, this is an example for walnut. Leaf out date of April 1st, typical of our Chandler variety. The estimate of ET for walnut, fifth leaf and older bearing. You can note this, our assumptions in our footnotes here, is 1.73 inches. Since this is a solid set sprinkler that's achieving about 98% total coverage of the orchard, it is throwing the water a farther distance than some other systems. And because of this, we have more wind interferences and different things. So sometimes these systems don't quite have the ability to achieve quite the same uniformity and efficiency of, say, a micro sprinkler or a drip system. And so for this purpose, I'm going to use an estimate of ET based on an 80% irrigation efficiency. So I'm going to be working with the idea that I want to know the maximum weekly run time to deliver 2.2 inches of water to replace the ET used in the past week. How many hours will it take to do that? There was no rainfall during this week, which is typical of this time of the year. And so there's nothing to subtract off there. And just a mental note, but to remind us that we do report the next week estimate just as a forecast, and to give you some idea of how much it might change from one week to the next. In midsummer, not much difference. In the springtime, this is a useful thing to pay close attention to. So moving forward with using the report information to calculate an irrigation runtime to really replace the past week of ETC in this walnut orchard. So here's the thought process and the math. Again, it's for the week of June 5th through the 11th, 2020. It's for the Durham farming region, and the crop is walnuts. The ETC was 1.73 inches with no efficiency adjustment for the irrigation system. I've chosen the 80% efficiency factor because of the nature of the solid set sprinkler. So I'm looking to determine the hours of runtime to apply 2.2 inches. And there was no rainfall to contribute towards that 2.2 inches of water use. As we walked through before, the solid state sprinkler applies water at 0.12 inches per hour. And so when I asked myself the question, how many hours of irrigation is needed to replace the past week of crop water use at 80% efficiency, the math calculation is fairly simple. It is 2.2 inches of ET divided by the 0.12 inch per hour water application rate, which equates to a little over 18 hours of irrigation for the week with this particular system. To try to help with making these calculations and as a means of double checking and maybe making it easier and more convenient, on the Sac Valley Orchard Source website, under the ET reports, there is this list of calculators, and you will see at the bottom of this list, there's a weekly irrigation scheduling tracker on a per acre basis, as well as a weekly irrigation scheduling tracker on a per tree basis. For this purposes, because we're talking about the ET rates in inches per week, and we have our water application rate in inch per hour, I'm going to be using this weekly irrigation tracker designated as a per acre basis. So if we just walk through this, here's the 2.2 inches of ET that I had taken from the weekly report at the 80% efficiency. Here's that 0.12 of an inch hourly water application rate. And so far in this situation, only 12 hours of water has been applied. The calculation is that the maximum weekly hours of irrigation needed is 18 hours to put back this 2.2 inches of water. So at this point, we've only applied 1.4 inches, or 64% of the ET that was estimated to be used last week, because we've only applied 12 hours up to this time. And this just goes through and shows the 18 hours is the maximum estimate needed, applied 1.4 inches up to this point, which is 64% of the reported amount needed. Okay, so we're completed with the walnut example. We will do the a prune example. We're going to be thinking of the crop ET being reported in terms of gallons per tree, and we're going to be thinking of a system like a single line drip irrigation system. Quite a different contrast to the walnut scenario. So here's, again, same week, June 5th through June 11th of this year. This time I'm going to look to the ET report from the Gerber South Station in Tehama County. For prune, this year our estimated leaf out date was March 11th. And for this past week of use, we estimate that the crop evapotranspiration was 1.81 inches. This was unadjusted for any kind of irrigation efficiency. Because this is drip and a fairly new system that I know has been well kept and hasn't had much wear and tear, I'm going to use a higher efficiency number of 90%. When I adjust for this, that increases my crop ET target from 1.8 to 2 inches for the week to replace. There is no rainfall to help offset the crop ET. And then just another reminder of the forecast of the next 7 days and the general steadiness of water use during the summer months. Oftentimes, a very common question is, why don't we report the crop ET in gallons per tree or gallons per vine? And it's understandable why that's a frequent question, and it's a good question. Because we can easily relate when we put in our irrigation system. We know the emission rate in terms of drippers. We know how many drippers are put around a tree, and we know the drip specifications. And same can be said for a micro sprinkler or a mini sprinkler as well. And so if the ET were reported in gallons per tree per day or per week, we could easily determine the hours of runtime for that week. The question we commonly get is, why do we not report ET rates in gallons per tree instead of inches? And some of the issues are is that the rate of ET will change depending upon the tree or vine spacing. We're unable to report ET rates for the range of potential orchard and vineyard designs in a concise one-page report. And then our ET, when we report our ET rates in inches, they actually are more easily compared and related to information about the soil water holding capacity of our soils, and they are more easily to relate and compare to rainfall that we might have received to offset the evapotranspiration. So continuing on with this example with prunes, single line drip irrigation. The situation is this, that prunes are typically planted at a higher density because they're a smaller tree when mature. In this case, there are 183 trees per acre, a single line drip with 7 1 gallon per hour emitters per tree when it's operating at 14 pounds per square inch. This equates to 7 gallons per tree per hour of irrigation. So we need to convert our weekly crop ET that was reported as inches, in this case for prunes 2 inches, we need to convert this to gallons per tree. So first we'll do it by hand ourselves. So we rely on that important conversion factor again of 27,154 gallons of water per acre inch. We multiply the crop ET reported for prunes to 2 inches by this conversion factor. Here is the calculation. 2 inches of ET multiplied by 27,154 equals 54,300 gallons for a week of crop ET. Yes, our crops do use a lot of water. It takes a lot of water to grow our crops, and while they're transpiring water, carbon is incoming, and that's the source of the sugars and used in photosynthesis to grow the tree and produce the fruit. The orchard design has 183 trees, so we divide the total gallons per week per acre. So we divide 54,308 by 183 trees, and this works out to be 297 gallons of water use per tree per week. Again, that may sound like a very surprisingly high number, but it's real, especially in the heat of the summer. We take this 297 gallons of water use per tree per week, divide it by 7 days in a week, and that works out to be about 42 gallons of water use per tree per day. So if you are not feeling like doing the hand calculation, again, we try to provide you some calculators on our Sac Valley Orchard website under the ET report section. So here you can see the 2 inches of ET plugged into the calculator, the 183 trees per acre that is planted, and here it's doing the math for you. Over 54,000 gallons of water transpired from the orchard per acre, which equates to 297 gallons per week per tree, or 42 gallons per day per tree. So using the converted ET in gallons per tree, Let's calculate the irrigation runtime to replace the past week of ETC. Thought process: how many hours of irrigation is needed to replace the past week of ET at 90% efficiency? The math: 297 gallons of ET per tree divided by 7 equals a little over 42 hours, 42.4 hours for the week of June 5th through the 11th to replace that water that was used by ET. And here is, again, using the online irrigation scheduling tracker to reinforce, double check, or make it more convenient for you. We put in the 297 gallons per tree per week of use, the average application rate of 7 gallons per tree. In this case, because this is a tracking calculator, we put in the actual hours applied. It shows 36 hours applied, while the calculator estimates we really, to match the full ET, the 297 gallons per week per tree, we need 42 hours. It's telling us that at 36 hours of irrigation, we've applied 250 gallons per tree, which is about 85% of the estimated weekly crop ET. So that completes this tutorial of how to begin using the information, the crop ET information, to estimate weekly irrigation run times. Now, in subsequent tutorials that are available to you here, we will talk about how this relates to soils, the water holding capacity of the soils, and from the tree perspective and crop stress, and get into a bit more of a discussion of why or why not, why it may or may not be necessary to apply the maximum ET each week. Thank you for joining me, and I hope you look into some of the other tutorials that are on this website.